Continuing practice 2 exam. That's 2 practice exam. Sorry. All right. You've probably watched hundreds of videos on electron configurations. Almost every one of them says, what number of electrons do you need before you begin? I do not do that because I have a tool that gets me to the answer every time without figuring out the number of electrons. Okay? So my tool is called the periodic table. I was pointing at it over here. And phosphorus. Yeah, it's there. It's element 15. So I got to get there on the periodic table. The first 2 elements on the periodic table get their electrons in the s orbital on the first row. So first row is done. You are now at the element called helium. You have to get to the element called phosphorus. That's what the question says. To get lithium, you'd add another s electron, but it's a 2s. To get to beryllium, you have to go 2s2. So 2s2 gets you to beryllium. I'm going to go all the way across the p's to neon. That was 6 atoms. You need 6 more electrons to get there. P number always matches the s number previous. What does he mean? 2s is followed by 2p. And because we're going to the end of there, we're going 2p6. You're at the end of the second row. Congratulations. Phosphorus is in the third row. We're about to be finished. To get to magnesium, you go 3s2. And I won't use green. 3s2. Now, you are not going all the way across the p's. You only need to get to the third one. I'm looking at the periodic table. 3p3 done, end of story, good work, you got a point. I'm thinking these are worth 2 points each. And I'm yeah. I think they were 2 points each. Circle around, yeah, it's perfect. I didn't read the 1 point each was for part B. Circling, it's now going to be worth 3 because I'm going to circle all the electrons that have the highest number in front of the name of the orbital. In this case, the number 3 is the biggest number in front of any of these orbital names. Do not circle anything at a level lower than that. So here's your circle, and there are the electrons. There's 5 of them. There's 5 valence electrons for phosphorus. The next question is about Lewis structures. You know that, right? So if you were asked for the Lewis structure here, I would write a P that has 2 dots together. That's these 2. And then we'll see which students really paid attention to when the P's get filled. Because some students will put 2 more dots for 2 of the P's and then a single dot for the third P. But the students who remembered what I said would put 2 dots and then spread them out. So once again, this is not part of this question, but you're doing in the next one. So let's get warmed up. So warm up in green, warm up. You don't need to be able to read it. Warm up. Here's the Lewis structure. Lewis. Yes, we have a question. Sorry? I can't hear you. I need to find the orbitals with the biggest number in front. Those are called the valence orbitals. And all the electrons living in the valence orbitals are called valence electrons. Thank you. All right. Zirconium. But zirconium has 2 less electrons than the atom on the periodic table. Well, how do I know that? It says 2 plus. So same number of electrons as what atom? Same number of electrons as which atom? The atom that has 2 less than zirconium, the atom. Is it Ni? No, it's zinc. Tisserhoff. And when you're in doubt, you better verify. If you're not sure which Z gives you zirconium, they are written on your periodic table. So we are here. We're going to there, right? SR. Strontium. That's the one that gives you the red fireworks when you burn them. Hey, perfect. Sorry. There is no ceruleum. I'm sorry. Cerium is Ce. Anyway, we got to stick with this. Zirconium. Where do the first two electrons go? Yes. Yes. I was going to copy paste from the previous example, but practice is great. 1s2, 2s2, 2p6, 3s2, 3p6. Where are you now when you say 3p6? You go to the third row, go to the end. Argon. All right. What's after 3p? Periodic table says 4s. And 3d10, because we have to get all the way past that. Yeah. 3p after p block. And remember, why did she go back to 4p and not say 3p? One, you finished the 3p. You've already written it. Two, the S and P numbers in front always match for the row. So 4p6, the same number in front of this S as is in front of this P. Now you're at, what are you at? You're at krypton, Kr. You need to get to SR, and you just finished krypton, so you're almost there, aren't you? 5s2, end of story. Put it in red or something, I don't know. Black. How do you know those are the valence electrons? Yeah, that's the only 5 in front of anything, right? Okay. So what do we have here? Yeah. Oh, I like that I could copy that. Answer that question. Same number of electrons for silicon negative as P. This is a coincidence, everybody. This will not happen on Wednesday, but if it does, you can say C answer I. Won't happen on Wednesday. C I above. It is the exact right answer. It won't happen Wednesday, but it's good. It saves us a little time today. You've already done P. That was a total coincidence that happened that way. Okay? Are we okay? I can stop. You want to do Lewis structure for zirconium? 2 plus, just 2 dots. They're together. And you put a square and a +2 because it's 2 plus in the question. And we're stopping here. She asked about the Lewis structure for zirconium. And we're ending so we can move on.